The topic is confidence intervals for proportions. So let's read the definition. Definition says interval of confidence is p hat minus z star square root of p hat 1 minus p hat over n, and then p hat plus z star square root of p hat 1 minus p hat over n. So let's do this example. In a poll taken in March 2007, Gallup asked 1,006 national adults. So n is equal 1,006. I don't know if we're going to need it. Whether they were baseball fans. 36% said they were. So p hat is equal 0.36. A year previously, 37% of a similar size sample had reported being baseball fans. Find the margin of error for the 2007. So for the 2007, we need to find the marginal error. Remember, marginal error is this quantity right here. So this is marginal error. So marginal error is equal z star square root of p hat 1 minus p hat over n. Do we have everything? Yes, except z star. So let's leave the space for that and write everything. P hat, we said 0.36. 1 minus 0.36 divided by n is 1,006. And then z star, since we're doing, what are we doing? 90% confidence. This is 90%, left 10%, so this is 0.5%, 0.5%. So this is a minus z star, this is z star. So how do we find the z star? Minus z star is equal inverse norm, use a calculator, of 0.005. Right, 0.5, move 2 decimals, yes. So minus z star is equal, if you use your calculator, you're supposed to get minus 1.645. So z star is 1.645. So I'm going to put 1.645. That's a z star. Right, this is 1.645. You have to use a calculator. If you do so, your marginal error will be 0.025. Done with this problem. For question B, explain what the margin of error means. Explain what does this number mean. And this is how you always do interpretation. We are, some percent is confident. So in our case, we are 90%, right? 90% confident that, and what does that mean? That means that p hat is within that margin of error of the true p. P is the proportion for the population. So in our case, what is p hat? Is the poll estimate, the poll estimate is within 0.025 is just 2.5% of the true population, the true P of the true proportion of the population. In this case, of all people who are baseball fan, of all people who are baseball fans. Alright, question C. If we want to be 99% confidence, would the margin of error be larger or smaller? I mean, we can calculate it, but if you notice, question D, we have to calculate it anyway. But they want you to answer this question without calculating. So, how do I do that? So, let's assume, well, this is a 90%, right? First of all, let me do this. First of all, we know the marginal of error. The formula is z star square root p minus p over n. So all of this is not changing. When we do a 99%, the only thing that's changing is z star. So let's assume this is 99%. So remember, this was a z star. Now this new z star for the 99%, the new z star will be larger, right? Bigger than the old z star. So therefore, if this number, this z star, z star get bigger, if you multiply it by the same thing, it means z star times square root p hat 1 minus p hat over n. Of course, it's gonna increase. So So in other words, this whole thing is just the marginal error. So marginal error will increase. So they want you to find the marginal error. We can even calculate it now, and you'll understand what we're talking about. What's the difference here? Square root of p hat was 0.36 times 1 minus 0.36 over n. This did not change. The only thing that changes is z star. Now remember, z star for 99%, 99. So this will be, let me do this, 99%, this will be 1%, 0.5%, 0.5%. 0.5% is 0.005, right? 0.5%, yes. So how do we calculate the new z star, or the z star for the 99% confidence? It's going to be inverse norm of 0.005. Of course, this is a minus. So if we do that, that would be 2.575. So z star is 2.575. So 575. So you notice if you compare these two, the only difference, this is 1.645 and this is 2.575. So of course we're going to get a bigger number. So in this case is 0.039. So you can see the marginal got bigger. In here it's 0.025, in here it's 0.039, right? So marginal error increases just as we expected it. All right. Now, do you think there has been, for question F, do you think there's been a change from 2006 to 2007 in the real proportion of national adults who are baseball? In other words, we're talking about P. Does P change? So let's see what we know. We know that P hat in 2006, let me see where we're reading. Blah, 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 blah. So in 2007, well, let's do 2006. In 2006, it was equal to 0.37. And P hat in 2007 was equal, what did we say, 0.36. So we want to know if P, the true P, those are just sample proportions. Both of these are sample proportions. If true P has changed. Of course not. I mean, why? Because here, so if we calculate just the interval, the 90% confidence, we got what? We got, is that 0.36? Yeah, 0.36 was a p-hat minus, what was the marginal error? 0.025, and then 0.36 plus 0.025. In other words, the interval was 0.335 and 0.385, and so you can tell 0.36, 0.37 is also in there, right? 0.36 of course is going to be in there. So the answer will be no. There hasn't been a change in the proportion of national adults who are baseball fans. And that's it for this example.